Well, hello there, Algebrainiacs. This is Mrs. Kendro. Some of you may not recognize my voice. Miss Johnson and I are working together on this video for you. It's called the Johnson Kendro Video Hour, but don't worry, it's not really an hour. All right, so today we're going to start notes on section 2.1, Relations and Functions. Now, I do want to point out one little thing before we start. You need to underline the word fun in your notes. Do it right now. We're going to wait.
All right, Mrs. Kendra wants you to underline that because she thinks that functions are always, always fun. I'm going to start off with some definitions. And the first one we have is a relation. A relation is a set of ordered pairs. So those are x's and y values, or input and output values. And we'll find out later. Some of these relations are functions, and sometimes they're not. But for now, we're just listing those ordered pairs within those pretty curly brackets.
And they are very pretty,
Thanks.
by the way.
Thank you. Okay, we've been practicing our curly brackets. The other definitions I have for you, domain and range, you probably remember these from Algebra 1. The domain represents the input values, or those would be our x values. And then our range values would be our y values or our output values. If you ever get confused, just remember the alphabet. X comes before y in the alphabet, and then D also comes before R. So that'll do it for our definitions. Mrs. Kendra is going to take you on to our first example, which I think has some Florida water temps in it.
Well, better than Michigan right now. All right, so we've got a chart here talking about 4 different months and their average water temperature. Over here to the right, it talks about the different ways to represent the information. The chart is nice and easy. Most of us are very familiar with charts. We have something called a mapping diagram, which you might not know about too much. Ordered pairs are also something you're familiar with graphing lines. So what we're going to do is we're going to take this information from the chart and we're going to put it in a mapping diagram. In the mapping diagram, you take the numbers or the letters. I'm going to do January, February, March, and April. And then I'm going to put their corresponding numbers in the other circle here. So 68, 70, 75, and 78. And usually in mapping diagrams, they show arrows. So in January, it's 68, February, March, and April. So we just show arrows to see which one goes to it, because there may be more than one month that has the same temperature. The other way to do this is ordered pairs. So we're just going to take those same bits of information and put them in the ordered pairs. So we're just making it look a little different, but same information. And one more, we have April at 78. All right, next I'm going to take that information and put it on a chart, on a graph here. So I have January was 68, so that'll go about right here. February is 70. March is 75. Wouldn't that be nice in Michigan? And April is 78. So all these different ways to represent the information. Some are more useful in other ways than others, but they're all useful at one time or another. All right. Okay, the next video slide we have here is talking about a function. A function, remember, is very fun. The second thing you remember is that each x is paired with only one y. You can't have 2 different y's or it's not considered a function. And scientists like functions because they don't like things that have 2 answers to them. So if it's paired with a different y, then you get 2 answers and things get confusing. All right. Each input creates only one output, and on a graph you can use a vertical line test, and we'll show you an example of that a little bit later. But for right now, I want to go through this next problem here, and we're going to find the domain and range. Remember, domain is your x, range is your y, in alphabetical order. So I'm going to list them. I'm going to underline them first just so I can get it straight in my head. Now I see 2 ones here. I'm not going to write that down twice. that's a waste of ink or lead. So we're just going to write it down once, and then the other ones. And notice they are in order, increasing order. Next, I'm going to do the range. So that was domain, now I'm going to do the range. So I have 3, 5, 5, 7, and 2. So 2 is the lowest, then a 3, then a 5, 5, which we count only once, and then the 7. So that's all you need to do when you list domain and range. Okay, now look at those lists of numbers, and we want to ask ourselves, is the relation a function? Is for every x, is there only one y? Now I see a 1 here with a 3, and I see a 1 paired with a 5. That's a big no-no. So this one is no function because it has two different y's for the same x. Now Ms. Johnson's going to tell you about this next problem.
Okay, we're doing the same thing in the next example, and we still need to evaluate that, or find the domain and range, rather. But what's a little different this time is I'm going to show you how to use a mapping diagram. Mrs. Kendro did a really good job just finding her matches from the list. Some of you might like a mapping diagram. So my domain, those are all my x values. So I've got a 1, a 3, another 3. She told us about not repeating those when you're listing, a 4, and a 5. So 1, 3, 4, and 5 are my domain values. I think my curly brackets are better than yours, Mrs. Kendro. What do you think?
Hate to admit it, but yeah.
Mrs. Kendra actually taught me how to make curly brackets, so maybe that has something to do with it. Okay, now my range values, those are my y's. Trying to go in numerical order. Here I've got a 2, 3, 4, 5, and a 7, I think. There we go. 2, 3, 4, 5, and 7. Now, Mrs. Kendra was able to just look at that list and determine whether or not it was a function, and some of you might not be able to do it just by looking. So here's another option for you. We're going to make that mapping diagram like we did on our first page. We're going to list our domain values in the one side, 1, 3, 4, and 5, and then our range values in the other circle, or oval, 2, 3, 4, and 5. And then we're going to match them up. Oops, I forgot a 7. We gotta make this just a tad bit longer and put my 7 in there. There we go. All right. Let's show our matches. So in the first ordered pair, I need to put my 1 with my 3. So I'll have an arrow going from 1 to 3. The next one, 3 should be matched up with 5. And the next one, 3 is matched up with 4. So I'm going from the same x value. Next I have 4 with 7. And lastly, 5 is with 2. So remember, to make something not a function, we would have to have the same x paired with 2 different y's, or maybe even more than 2 different y's. And if you look, we have that happening with our 3. 3 has arrows going to 2 different numbers in the output column. So this is also no fun ka-chun. Right, Mrs. Kendro?
Right on. All right, so we talked about vertical line tests earlier. Now we're going to show you what that really is going to look like. So it says if a vertical line at any point touches the graph more than once, then it is not a function. All right, not a function. So I'm going to do a vertical line. That's up and down. See, it hits it here and here. Do another one straight up and down. It's going to hit it here and here. So there are lots of places where it hits. So this is not fun. All right, the next one has just a diagonal line, and I can do a vertical line all kinds of places, and I'm only hitting it once with each vertical line. So that means we're having lots of fun. Yes, sirree. All right, function notation is the next thing we're going to talk about. Function notation, mathematicians like to make things fancy, and function notation is just another way to represent y. Y is the same as f of x. Remember, y is your output, x is your input. Over here on the right, f of x is still your output, and x is still your input. So it doesn't change anything. It just looks a little different. Over here, this is x and y. Instead, they write it x and f of x. So the next problem we're going to do, we're going to evaluate, which means find the value. And we're going to have fun doing it. Don't forget that. And so now look at this problem. It says f of x is x plus 5, and they want you to find f of 3. See how that 3 sits in the same spot as the x? That means the 3 is your input. Okay, when I go to write an ordered pair, my input is going to be in there already. So I already know what my x part of my ordered pair is. So I'm going to do f of 3 equals, 3 plus 5. So f of 3 equals 8. Another way to say that is that y equals 8. So I put that over here. You've got your ordered pair. And really, it hasn't changed a whole lot. All right, Ms. Johns, I want you to explain that last one and bring us to a conclusion.
All right, in our second example, this is still a function even though they use the letters g and y. You will see that from time to time. This time they want us to find a g of negative 6. So like Mrs. Kendrow told us, this is our input value. So we will go to the g equation. We are going to use negative 6 as our input. Therefore, we will replace our variables with negative 6. We want to follow order of operations. And when we do that, exponents need to be done first. When I raise negative 6 to the second power, we should get positive 36. Then we will have to multiply it by 3 and subtract 1. 3 times 36, that's going to give us 108. And then I subtract 1 for that, we get 107. That's our output value. Remember, the directions did ask us to write it as an ordered pair. So the input that we used was negative 6, and the output, or the y value that we came up with, was 107. All right, last example we're going to do. This time we're going to have to come up with our own function. So write a function rule to model the cost. Okay, to do that, we need to know the situation. And I think the situation is actually going to be about food. So here's what's going on. We're going to go and buy pizza dinner.
Yay, I love pizza.
I like pizza too. Pizza, we're going to have some food and we're going to have a drink. That's what our dinner will consist of. They tell us that each pizza slice costs $1.50 and then each drink costs $2. Write a model, then evaluate the cost for 3 pieces of pizza. So when they say a model, that's just writing a function. And then we'll come up with how much it costs. We want to find out what our variables represent. So the things that I don't know how much pizza we're going to eat, and I don't know what the total amount of money is going to be. One of those should represent x, and one of those should represent our y, or our f of x value. So think about what you need to know first to determine the other. And I think we need to know the number of slices that we eat, or that we buy, and then that will determine our total cost. We're asked to write a function to model the situation. I have $1.50 that I have to pay, and that is per slice of pizza. And remember, x is representing our slices. So $1.50 should be multiplied by our x value. Per means multiply. So $1.50 per slice. I also have to buy a drink. How many drinks are we going to have to drink, Mrs. Kendra? What do you think?
I can only have one.
I think so. We might be able to eat more than one pizza, but our meal only comes with one drink. So that $2 cost, that's only going to be a one-time thing, so there's no variable attached there. So that's the first part. That's our model. The next part, we want to know what is the cost going to be for 3 pieces of pizza. That means our input value is going to be 3. If we want to find f of 3, we will replace our x value with 3, use order of operations, and simplify. Multiplication should come first. We should get $4.50 when we multiply by 3. Adding 2 more to that, that's a total of $6.50. So that's our meal. All right, I think that'll do it. Mrs. Kendra, what do you think? Are they ready?
They're ready, and I'm hungry, so we're going to end this video.
All right, see you guys in class.
Bye.